Hello, good morning or good afternoon, depending where you are.
Good morning.
So, hello, Heinz. Hello, Nabi, and welcome to Bertrand Chambion. We have a big pleasure to have you today here during the coffee chat. So I hope everyone has his coffee ready to listen this nice discussion. So Bertrand is working in France at CEA-LITEN and working on vehicle integrated photovoltaic module. So now we already have some photovoltaic module in car, like the Prius, Toyota Prius, or other also Hyundai. Like now in CA, what are you doing new, and what are you bringing? What is the limitation of today maybe module, and what are you doing in France to improve this even further?
Okay, so hello everyone. Thank you, Antonin, for the introduction. And let's introduce maybe the activities in CEA-INES. So just INES, as you can see just behind me, is in the French Alps, so located close to Chambéry. And we are approximately 400 people working in 3 main teams. The first one on sales development, or next generation sales. The second team is focused on systems and PV module and systems. And the next team is dedicated to networks and smart grid and connections between renewable energy and the grid. So the VIPV team is focused on PV module and systems team on service. And the VIPV team so aims to cover all the subjects we need to integrate PV on cars, on electrical cars. And for example, one of the key points for VIPV applications is the irradiance data we need to collect from the sun to the car, of course. But we need to know the exact data and maybe some effects like shading, and just to know exactly the energy we can collect and we can store on the vehicle and to use in the motor to the wheel and to move.
So that means you have a specific car which with plenty of sensor to trace all this data. Like
yeah, that's true. So we have some different axes to develop. So one of them is irradiance monitoring. So we equipped a lot of cars with specific sensors, so to collect data from the sun directly, and to know as well as possible the solar energy we can collect from a car. And we have also some prototypes dedicated, focused on the vehicle now, just to collect other data like current or voltage at different level in the car, just to extract efficiencies and to have a realistic model for cars.
I have a question, because for me, yeah, you drive the car not very often compared to when it's parked. So what's the ratio between the energy you get while driving and the energy you get while parking? Because sometimes we are working really hard to have get as much energy also while driving.
Yeah.
Is it worth to do effort there, or it's only during parking?
So thank you for the question. It's a very good question because it depends on the use case of the vehicle. For example, if you take an urban buses, for example, or urban bus, so the major part of the day the bus is driving, that's moving. So it's not the same use case as a standard car, passenger car, for example, which spends more than 90% of the time in parking phase. So it's not the same strategy to collect the energy. So it's not the same architecture in terms of vehicle architecture. So we need to adapt for each type of vehicle and use case.
Okay. Yeah, thank you. And yeah, also one question to Heinz. How is it going in Philadelphia? Is that good?
Yeah, I just wanted to point it out. We had yesterday a very nice presentation from Toyota Research, actually, my friend Masafumi. He's drifting more and more really to see the whole part of the car. And he made a presentation saying what chances we have as a function of efficiency of solar cells. And he basically was postulating that for passengers cars, you need to have 30%, because it's a little bit also a question of user behavior. For example, in cities, you have a lot of partial shading. Not always people want to park the car in the sunshine. And he was showing this very nice graphs of an expected driving range per week as a function of efficiency. And he was also claiming, well, efficiency is expensive, but it's still affordable if you compare the whole cost of a car. So are you modeling or having experiences in higher efficiency applications on a roof?
Yeah, so we have some models to predict the kilometers we can get from the sun in the vehicle. So, and we found that there are some very interesting conclusions. For example, I agree with you, as you have just said before. We need for sure to cover as much as possible the cars of solar cells. So for sure, we need to improve the efficiencies of solar modules also. Mm-hmm. But I think that we forget too often the car efficiency. I mean, for example, the self-consumption of the car. Because in the car industry, there are a lot of regulations, constraints, and we need to wake up a lot of things just to charge or to wake up or just to turn the key. Everything is wake up, and a lot of consumption and watt hour are consumed in the vehicle and not by the motor.
He was pointing to something like above 6 kilometers per kilowatt hours. This is the range where Toyota is looking into it. Obviously, they can meet this with a Prius, but it's not the standard of electric cars today. It's more between 4 and 5 kilometers per kilowatt hour, or the other way around, 200 watt hours per kilometer. And so that's practical. But he was very positive regarding trucks. Okay. In particular, I think he was referring to cooling trucks, so trucks which need air and cooling system, and that would help a lot of CO2 reduction.
Okay, so for the consumption, so in passenger car, for example, we consider that 150 watt hour per kilometer, is the mean value.
6.5 kilometers per kilowatt hour. Yeah. Okay.
Yeah, so it's the mean value, and for buses or trucks, it's more like 1 kilowatt hour per kilometer. Mm-hmm. So it's 10 times more approximately. And for sure, the more the surface of PV is on the vehicle, the better will be first the energy collection, of course. It will be easier also to store due to the efficiencies and at the commercial levels in the vehicle. And also for the CO2 balance, so the final CO2 balance at the end of the vehicle service. Mm-hmm. It will be easier to have a positive balance with a large surface of PV, because the PV is the only one component that pay back the initial footprint for CO2. Mm-hmm. And for the initial footprint, it's easier to have a positive balance for a bus or a truck than a passenger car. So mm-hmm. Yeah, so this is the first tendency we can have on the VIPV applications, but we need also to work again and to continue to work on it to be more precise in terms of predictions.
Mm-hmm. In passenger car, there are also quite some windows. Do you think we could also use partially the windows to produce electricity, or is it just a dream? And what is your feeling on that?
The windows, I think it's nice for concept cars at the moment, with other technologies such as transparent or semi-transparent technologies. I think that these kind of technologies are not reliable for the moment, but it could be interesting to imagine, yeah, them maybe as a rollable technology in for Windows, for example. Yeah, we can think about it.
One idea that comes to my mind after what Antona asked us question regarding the window usage and all these things. Mm-hmm. Of course, that's we think and about solar, only solar to power the cars. But one of the idea is a combination, because I always say that we cannot have only one solution to solve the overall problem of the energy. We have to combine different forms of energy to answer the demand, whether it's domestic, whether it's for the industry, whether for whatever. So one thought, which is completely fancy, and they didn't see any concept developed combining, for instance, the wind and the solar. You know, for instance, if we can maybe design something that has, for instance, no more than that height, maybe 10 centimeters height, you know, a system with the turbine, with something that can, you know, generate a power like a turbine. And then when the car is up running, also, it can generate the electricity and also increase the range of the distance that the car can go through. And it could be a kind of combination between the solar panels. Okay, we can have the top solar panels and can go, for instance, and one of the thought that I have is, for instance, the space that we can have between the top of the car and the solar panels to use kind of wind turbine, and to make it running like that, we can increase somehow the power, the range.
It makes me think about, did you see the movie on the last Mercedes car? They try to have spoiler to improve efficiency. So while you're running, they go out with some spoiler and you improve the aerodynamism of the car. But yeah, to have some wind turbine to push or to make electricity, that's my question, because it's not clear if you can use both ways.
Exactly, because today I think that's if we apply fully the car, I would say the range won't be more than and we power just with the 30 kilometers, maybe 50 kilometers others are claiming, but it's still, you know, it's quite limited, and it's quite dangerous to take the car and to drive it from point A to point B. But looking for how we can increase the efficiency, you know, and the range, that would be one thing. The other things that I wanted maybe to ask you, if at CEA-LITEN you are working on, is, for instance, to have the body of the car, the entire body, covered with the panels.
I think I prefer this idea.
What?
I prefer this idea compared to the windmill integrated. So I think that for the windmill concept, you will consume the energy to compensate the windmill generation while driving, but maybe we can have some work to anticipate, maybe, yes, for parking phase. maybe on a very windy zone or location, maybe it could be interesting. Yes.
Well, it's
For parking also.
For parking, but yes, please, Heinz.
I think you need a very sophisticated aerodynamic design to avoid that you create additional drag. I think it's not impossible, but you need a careful analysis where a current drag is produced in a car and how to put there whatever kind of wind generator, because if you make additional drag, all your energy is lost again. And a wind generator, okay, can have an efficiency of 50–60%. That's good. It reminds me a little bit of there have been, as also boats are vehicle integration PV, there were concepts which have foreseen basically a catamaran boat, and you put a normal wind generator on top, and you would sail into the wind, and as the parent wind is higher as the rear wind, you would gain a lot by this generator. And there was a big debate about this, and then you make an electric drive, so you have sail plus electric, and having this wind generator, what is the maximum speed you can have, because it could go to infinity. So if you go against the wind, I mean, just having the wind in front, and this were endless debates, in particular on parties of physicists. And so it reminds me a little bit of what can be done. But, well, in fact, even it sounds surprising, but when you're coming from sailing and you know that the parent wind, it's much higher than the rear wind speed.
Yeah.
So I used to use ice sailing, so, you know, on frozen lakes with a kind of sail slit. And you can have 120 kilometers per hour just with 10 knots of wind. And so I would not discard this entirely, but you need a very, very sophisticated aerodynamic design to make this efficiently working. So the other point that, I mean, extending the question of before, where to increase the surface area. If you think of lamination processes of cars which have a considerable amount of carbon fiber, and I can imagine that the manufacturing process would allow for integrating into the lamination process already solar cells. And then you would have them wherever the car wants to have it and from whatever angle. Is that something which one could see in one future?
In terms of integration, yes, the idea is to integrate the cells within the car body parts in the future, for sure. And to answer also the question of Nabi, of course, to cover all the surface of the car is a very good idea. Even if the cells are not efficient as they could be on the roof, for example, or in the solar farm, for example. But for the range extender, it could be better for sure. So we have some models to predict this in CEA and in the team, and we know that it's interesting to cover as much as possible the car of solar cells for the range extender development.
Yeah, and also we can even for instance change because the car, since I would say it was invented nearly more than 100 years ago, it remained the same design of the car. We have 4 wheels, we have front, we have middle where the sofa and the people are sitting, and we have the back. So maybe we should think also in the design of the car to have another design that's allowed the maximum surface, for instance, to be, I would say, presented to the sun, and then have, for instance, less surface at the sides or front or back. The design must be worked on. When I see, for instance, just the picture that we have here in our background for the Lightyear car, the design is remained the same. It's the same concepts of the car and the same design. I think that's one of the things that the car makers have, or the companies who are now working to produce very, I would say, efficient solar car, is to think about what would be the best design that allowed the maximum surface
Yeah, I agree.
That's hard.
Yeah, this is a point we need to also to develop with car makers, is to integrate the PV at the beginning of the car development, because nowadays it's just a plugin. We just want to integrate PV with the existing solutions without PV, so it's not optimized at all. But the idea is to integrate the PV technology at the beginning of the car development. This is a key point for me.
Yes, it's exactly. We should start from, I would say, a white paper and see exactly we have panels and what's would the maximum surface that we can have, and in order to and then design the car, not to do the contrary, because we're always limited. We are always limited in terms of surface.
Yeah.
The other things I don't know exactly about your work regarding, you know, because you mentioned the cell efficiency, the efficiency of most powerful modules. And always I'm thinking, and I know we had already such discussion in one of our coffee chats with Christophe Balif regarding the V3 cells, which are, of course, the cost is over $100 per watt, but something intermediate, you know, something which is roughly, and we can think about the luxury cars, about the luxury cars, and we have this kind of cars powered with and where we can use these kind of cells, which are extremely. What's your projections, your point about that?
We heard a lot that tandem cells or maybe perovskite cells could propose a higher efficiency in the future. So it could be a solution for VIPV, interesting solution, coupled also with a heterojunction substrate to be less sensitive in temperature, for example. So we are expecting this solution, but to complete your question or your remark, maybe also we need to increase the efficiency of the module, but also rethink also the cars. For example, the best seller at the moment are SUVs, so it's not the well optimized car in terms of energy consumption. So maybe we need also to think about the consumption and not only the energy generation.
In my humble opinion, we can group stepwise. You know, when Tesla started maybe 15 years ago, they start with that concept car, which is how to call it, a Sportster. Is the Sportster cars, two seats and a very, very light car. They took the body of the Lotus. They took the body of Lotus and then they make it electrical. Body, the Lotus is well known that it's 600, 700 kilograms. And this is how they start. And we can think also in terms of this, I would say, new generation, I don't know how to call it, or improvements of the EV cars to make it really carbon free, it's really renewable energy 100%, is to have, I would say, kind of transition. As for instance, some companies, I don't remember the names, they are, for instance, trying to promote for the transportation of the goods inside the city for the delivery. For the delivery, they have special design for their truck and these kind of things like that. These cars, first of all, they are always outside. Second, they don't really drive for long periods of time. They always drive and stop, so it can be charged. So we have to change our idea and our way of thinking these kind of things. What do you think, guys?
I think it's use case driven approach. I think there are a lot of cases we need to understand and to optimize. We cannot generalize the VIPV for every vehicles. first. This is, I think, this is one of the basic points. Compared to other vehicles like bus or trucks, for heavy vehicles like bus or trucks, we need also to rethink the concept in terms of use cases, and also to have a breakthrough. I mean, for example, for a truck maker, the interest is to be non-dependent of the engine. So the ideal world could be only solar, but without any gasoline. But it's not possible due to the surface we need for solar PV, solar panels, compared to the power engaged in the vehicle. It's not compatible at the moment. So we cannot unplug the engine instead of solar at the moment.
There is
in the future, it could be interesting to see if the balance is reached or not.
Thank you. There is a question from the people watching the chat. So it's from Kaishi Komoto. What will be a renovative integration into car body? How can we like refurbish a car with let's say solar? Maybe that's maybe the question. And what would be the cell technology used in the future also for VIPV?
Okay, so I think so. Hello, Keishi. I hope you are going well. And I mean that what will be the technology in terms of solar cells in the future for VIPV?
Yes.
Okay, so I think due to the shape and due to the specific design we can meet in the automotive, I think that the cells in the cars in the future, the ideal cells will be the standard. I mean the standard cells and strings from the industry, from the PV industry. But I think that specifically for cars, we will need to cut cells and to make specific strings and designs for each cars or each car models. This is my opinion, but I think it will not be possible to have a standard cells and strings in automotive.
And like a back contact cell, so you have no like a white color in front and cut in small pieces. That will be
back contact will be also a solution in terms of dicing, also in terms of integration.
And I found maybe I already shared this also to refurbish an EV. You have this EV solar kits. I will share in the chat. That seems to be quite interesting because that's true. I mean, you have a limited surface on your car, and then as soon you park, you can extend it, like just having, like in a campsite, you extend your part, and I think it could be a solution, especially when you have space around, just to have this kit you extend and you can recharge.
Yeah, one could take the mechanics of a cabriolet. You know, mechanics of a cabriolet.
Exactly.
Yeah, but this is a very interesting point because we have at the moment a prototype in monitoring with this concept, the solarization kit for EV, and we are at the moment trying to test some interfaces between the solar panels and the car.
Yeah,
I've seen that.
So it's okay. So this solution is integrated with the car manufacturer because we need the car manufacturer to integrate it. And in our lab, so we try to develop a standard solarization kit without the car manufacturers, just to solarize any electric vehicle in after-sale solution.
So that means you have like in your car, you just take out the box and then you open it and then you can plug it directly in the plug of your electric EV.
But
I
don't
mean,
use
yes.
it for sunbathing then.
So you are talking about the EV solar kit or the
Yes,
solution we are developing in
the
in
solution
CEA?
you are developing.
Okay. So the idea is to be non-intrusive to the vehicle, so no modification in the vehicle. And the idea is to put the solar panels, a specific kit in the trunk, for example, and a specific interface with the vehicle to transfer the energy in the car during the plug-in at home or at work in parallel. So the idea is to store the energy and to transfer it in the car during the car charge standard phase.
Very interesting.
We are in progress on this subject.
I think that there are quite interesting solutions that could be applied. Of course, that's today we expect that we can drive the car 1,000 kilometers without stop. And even I was discussing with one of my friends who acquired the EV car, and I told him, how do you deal when you are traveling, for instance, between over 300, 400 kilometers? He says, well, we normally stop. In any case, to have a coffee, to relax some minutes, the stop will be just maybe a little bit longer, maybe instead of to be 10 minutes, it's going to be 20 minutes. And then you can load the car and you can move. For I would say the other step for the solar cars, I would say, solar cars, could be maybe for another usage at the start, but the more we deploy the cars, because one of the problems that's for the cost, if we consider, for instance, this high efficiency, and just recently, for instance, Fraunhofer Institute, they published something about four junction, and they reach over 46 efficiency, which is extremely high. We can imagine the cost of production and how it's going to be reflected. But with more deployments, and we have to choose the market segments where these cars could be used, then with that deployment, I think that the more low will start, and then we're going to see a drastic decrease on the price of such shares. And of course, automatically, we can have more range on them for these VIPV solar cars and so on.
Okay, so 46 is just twice approximately 2021, 22, 23, sorry. And maybe we can also consider that we double the surface with actual PV technologies on cars. And with this surface, we cannot reach the entire range we need for all of the placements in a standard use case. But we will stay at approximately 10% or 15% of annual kilometers with solar. So it will be very complicated, from my opinion, to cover all the need on a year. But it will be a part, so we can complete with other energies for the rest of the range we need.
You know, any new idea, especially a revolutionary idea, starts with 3 steps. First of all, it's impossible. We cannot use it because we'll never cover the range. It's impossible. It can't be. No. Then is the other points and the other phase. It's going to be off. It's ridiculous. It won't work. It won't work because the cost, nobody will buy it. And the last step, which is it's obvious. And I think with any development, it passes these three phases. Today we are, it's ridiculous. We cannot have that the needed range. But if we start at the beginning focusing on a market segment, most of the people, and this is the study that has been, let's say, made several times in different areas in the globe, we run less than 100 kilometers a day. So we can see exactly which market segment it will be interested in. And starting from that point, we can enlarge while developing that concept and also reducing the costs.
I think that one of the first market will be the electric buses, so urban buses, to collect a maximum of energy with well-adapted surfaces, and also for CO2 balance, it's quite interesting, even in Europe, with a quite decarbonized energy mix in terms of electricity. So the electric buses could be a good market to begin with this technology.
Yeah, so thank you very much. I think we are reaching quite the end of the discussion, but was very, very interesting, and we don't want to stop, but I think we have to continue. I don't know, Brian, if you want to add a word for conclusion.
Well, I always like to just put my face up here so I can put my credit on YouTube. So, but generally, I thought it was a great discussion. And Bertrand, thank you so much for joining us today.
Welcome.
And also, of course, thank you for those in the audience that joined us as well. We record all of these presentations, and you can find them on the links on our website, solarunited.org. So we will have more of these in the future, but if you want to watch one that you might have missed in the past, you could always watch it online at your convenience, sitting in the office or sitting at home. But yeah, that's all I wanted to say. Thank you, Heinz. Thank you, Nabi. Thank you, Antonin. Great discussion as always, and look forward to seeing you guys all again very soon.
Thank you so much, all. Thank you. Bye-bye.
Thank you.
Bye.
Bye-bye. Thank you.
Bye. Bye.